All right, this is the continuation of our discussion from class today. We had a few questions on our review time that we did not get to. So I have them marked here. We needed to do the standard deviation part of number 21, 22, 23, 25, and 26. All right, so let's look at this. So to do the standard deviation, if you have a set of data that is just a list, so there's no frequencies listed specifically for us, I will point out there was an error on the answer key on this one. For the median, it should have been 67.5. I think I had typed in the back 67.7. But if you list these in order from least to greatest, 67 and 68 are both in the middle. And then when you have just a list, you find the median by adding those together and cutting them in half. So just as a correction to the answer key for that one. But to do the standard deviation, you have to have the mean first. So if you do the mean, you're going to add up all of your values here. So let us do that real quick. So I've got my calculator. If I add 72 plus 70 plus 68 plus 67 plus 66 plus 67 plus 63 plus 71 plus 65 plus 74. That gives me a numerator of 683. I have 10 items. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the average number is just the total number divided by how many items. And that is 68.3. Okay, so when you need that to be able to find your standard deviation. So we do kind of a chart for standard deviation. So you have your items, and then you take each item and you minus the mean from it. So that's your X bar symbol. Then we square that. And since this is just a list, once you square it, we will sum those up. And that's going to be in our standard deviation formula. That sum is going to be our numerator. So whatever we get here, it's going to be our numerator. And then we always divide by number of items we had minus 1. So that'd be a 9. Okay, so we need to do this part. So I have 72, 70, 68, 67, 66, 67. I'm gonna have to erase some of this so I have room. And then we have 63, 71, 65, 74. Now I'm under the inclination, usually when I do these, I just go ahead and work this all the way across before I move on to the next number. So 72 minus my mean, which is 68.3, that gives me 3.7. So that's going to go in this first blank. We then square that on our calculator, and that gives me 13.69. So there's the first one. And then we have 70 minus 68.3. That's going to be 1.7. We square that, just kind of drawing lines to separate. That's 2.89. And we do 68 minus 68.3. You always subtract your mean. That's negative 0.3. Now, when you square this on your calculator, if you don't put the negative in a parentheses, it doesn't know to square the negative. Your answer should be positive when you square. So this should come out to positive 0.09. 67 minus 68.3 is going to be negative 1.3. So negative 1.3. Then we square that, and we get 1.69, because remember, when you square a negative, it should square the negative. So if your calculator's not doing that for you, you need to put the answer in a parentheses to square it, or you just need to remember that when we square it, it always should be positive. 66 minus 68.3 is going to be negative 2.3 for this next one. That's the difference. And then we square that, and we get 5.29. 67, we already did that one once. That's a repeating value. So that's going to be a negative 1.3 again and a 1.69. 63 is a new one. So 63 minus 68.3, that's going to be negative 5.3. We square that, and we get 28.09. 0.09. We need to do 71. So 71 minus 68.3. That's going to be 2.7. Square that, we get 7.29. And then 65 minus 68.3 is negative 3.3. and we square that. That's 10.89. And then we do 74 minus 68.3. That's 5.7. We square that. Oops, sorry, that doesn't look like it wrote in very nice. So 5.7, we square it. We get 32.49. Now you need to sum that whole last column. When you're doing a list, you don't have to do anything else beyond the squaring part. So if you have all of your data, you just add these all up. So 13.69 plus 2.89 plus 0.09 plus 1.69 plus 5.29 plus 1.69 plus 28.09 plus 7.29 plus 10.89 plus 32.49. Okay, and that gives me 104.1. Now that is going to be my numerator in the formula for standard deviation. So for this specific problem, if you have just the whole list of data, so you know all the items, you find your mean first if you're trying to find standard deviation. You write each item down, you subtract the item minus the mean. So some of them are going to be positive, some of them are going to be negative. You square all of those, so then they all become positive. We add all those values together. That's my numerator. Then we divide that by the number of items we have minus 1. So this is 10 items, minus 1 would be 9. And then the square root is to undo all of the squaring. We squared because we didn't want to add these together when some of them are positive and some are negative. That actually equals 0. So that's why we do this. Because not all standard deviations can be 0. That doesn't make sense. So then we would go on our calculator and you do the square root of 104.1 divided by 9. You can put that whole thing under a parentheses in the square root. And that gives me about 3.4. Excuse me. So that's the standard deviation part. Now that was all I was asked for specifically. We did have to find the mean to do that part, but that's what y'all asked for in class. Okay, so let's talk about how to do number 22. This is what we call a grouped set of data. We don't know what values we actually have here. We just know we have 2 values in our list. This is an unknown list, essentially, that the values we have are between 0.5 and 1.5. So that could be 2 ones. It could be a 0.75 and a 1.25. We don't know, okay? But we have 2 values in that group, 8 values in this group, 3 in this one, 2 in this one, and 3 in this one. So when you have a grouped set of data and you want to find the mean and the standard deviation, first thing you have to find is the mean again, because that is how we find the standard deviation. So to find that, we're going to do what's called the midpoint as an estimator. Okay. So to find your midpoint, the first one is always a good place to start. You add your 2 values that make that interval together and we divide it in half. So that's going to be 2 divided by 2. So this first midpoint is a 1. Now, if you notice, each of these is going up by 1. So if you look at the beginning of each interval, the class width is we're going up by 1 exactly. So that means each of our midpoints will go up exactly by 1. And if you think about it and you look at these, it makes sense. Halfway between 4.5 and 5.5 is 5. So these are my midpoints. Now, to find the mean of a frequency distribution, you have to remember we're using this value, the midpoint, as an estimator for the entire interval. So I know I have a 1 and I have 2. We're saying that's our estimator, and this is how many we have. Plus, I have a 2 for my second midpoint, and we have 8 of those. Plus, I have a 3 as my estimator, and then I'm going to have 3 of those because that's the frequency. I have 4 as the midpoint for my estimator, and I have 2 of those. And I have 5 for my last estimating point, and I have 3 of those. Now, what you divide by is not just I have 5 rows here. It is how much frequency do we have? That's our N. So that's 10, 15, 16, 17, 18. There's 18 values here. So we're going to divide by 18. So we get our calculator out. You're going to have, let's see, that's 2 plus 16 plus 9 plus 8. You can obviously type it out with all the multiplication if you want, and plus 15. So my numerator is going to be 50. My denominator is 18. Just double checking I got that right. Yes. So 50 divided by 18. They told us to round answers to 1 decimal place, nearest tenth for all of this. So that's going to be 2.8. Okay, so there's my mean. Now I'm going to do my standard deviation, and then we are still also supposed to draw a histogram to represent the data. That's just making sure you know how to do a histogram. So standard deviation for this set, it's similar. You do, I call it X sub K when I have a midpoint, because these, remember, we don't know if these are the actual items. We just know they're a good estimator. So 1, 2, 3, 4, 5, the midpoints. They're the halfway point of each interval. Then we take each of those and we minus the mean we came up with. Same thing we did previously. Then we square that to get it all to be positive. The extra step is because each of these estimators occurs more than once, they're not singular answers in the original set. You have to times each of them by the frequency for that group, okay? Then you're going to get the sum of that. Now that's going to be my standard deviation formula. I'll have that sum on the top, and then it's n minus 1, not 5 rows. I have 18 items, so I'm going to be dividing by n minus 1, so that'd be 17. Okay, so let's do some of the math. So 1 minus 2.8 is going to be negative 1.8. I always just go all the way across this whole row. We square that, we get 3.24. So I'm just using my calculator. And remember, if you square something, it should come out positive. If your calculator's not telling you that, then it's because you're not putting your negative in a parentheses. Your calculator may not know how to do that. So then we times that by the frequency for this row. Now the frequency for this row is 2. So to get this answer, I'm doing 3.24 times 2, just to show you. I'm not going to write that on each row, but that's how I'm getting this. So that's 6.48. Okay, so that's my first one. Then I'm going to do 2 minus 2.8. That's going to be negative 0.8. We're going to square that. That's 0.64. We're going to times it by its frequency, which is 8. And that's going to be 5.12. So just for reference, I'm just going to show this one as well. Just so you know, we don't multiply by 2 every time. We multiply by the frequency. Okay. Then we're going to do 3 minus 2.8. That's going to be a 0.2. We square that and we get 0.04. We multiply that by its frequency, which is 3. And that's going to give me 0.12. Okay. And then 4 minus 2.8 is going to be 1.2. We square that. That's going to be 1.44. We times it by its frequency, which that group's frequency is 2. We get 2.88. Okay. Last one. 5 minus 2.8 is 2.2. We square that. We get 4.84. We times it by its frequency, which that row has a frequency of 3. So that's 14.52. Now I'm going to add those all together, and that's going to give me my numerator for my standard deviation formula. So 6.48 plus 5.12 plus 0.12 plus 2.88 plus 14.52. That is a numerator of 29.12. So I'm going to be typing this into my calculator, square root button, 29.12 divided by 17. Close the parentheses, and I'm getting 1.3 if I round to the nearest 10th, which they told us to round to the nearest 10th. Okay, so to draw the histogram, you're going to come over here and you're going to make a little break in your graph so we know it doesn't exactly start at 0. You're going to put the actual interval endpoints, so 0.5 to 1.5, then to 2.5, then to 3.5, 4.5, and 5.5. That was the last interval. We need to have at least a height of 8 for the frequency. So I'm just going to count by ones. 1, 2, 3, 4, 5, 6, 7, 8. For the first group, we're going up to 2 for the frequency. So you make a bar from the 0.5 to the 1.5. And then for the next bar from 1.5 to 2.5, we go up to 8 as the frequency height. So these are our frequencies over here. For 2.5 to 3.5, we have a height of 3. For 3.5 to 4.5, we have a height of 2. And for the last one, we have a height of 3. Okay, so there's my histogram. All right, let's look at number 23. It says, according to the college survey, 22% of all students work full time. That is a probability that students work. Okay, probability can remember be written as a percent. round to 3 decimal places as needed. So my first thing is when I just see percentages as the data represented it to me, I know that I'm usually probably dealing with a probability of success because either students work or they don't work full time. Okay, that's the two options. You either do it or you don't. So the probability you work full time, which is what we're kind of telling you that the variable is going to be 0.22. Remember, the probability you don't work full time, that's going to be 1 minus that. So that's going to be 0.78. And then they told us we're doing a sample of size 16. Okay. So this is a binomial distribution where we have 16 people in our trial and either they work full time or they don't. So we have a probability of success and a probability that they don't, or a probability of failure. Okay. And it's independent from each other. That's also required for binomial because each student's work status is not related to another student's work status. So we want to find the mean. So we had a formula for the binomial distribution. The mean, which we have this little mu symbol, is the number of trials times the probability of success. So it's 16 people times the 0.22. So the probability that they work. This will tell us about how many people in the group we should expect to be full-time workers. So 60, and again, sometimes it's a decimal, that's okay. It's just a long-term average. So this is about 3.52, okay? So that's our average. Find the probability that exactly 6 of the 16 students work. So this is our probability of success. That was our X. Remember, we had a formula for a binomial distribution. It's N choose X, probability of success for X times, probability of failure for the leftovers, whatever, however. So if you have 20 trials and you have 5 successes, you're going to have 15 failures. So that's what that little subtraction is. So we're doing 6 successes out of the total 16 people. So that's going to be 16, choose 6. Probability of success is 0.22 to the 6. So 6 people are successfully working full time. And we have 0.78. That's the probability they're not working full time. If 6 people out of 16 are working full time, that means 10 of the 16 are working not full time. So they could be part-time workers or not working at all, but they're just not working full time. So you would do your choose button on your calculator. So 16, choose 6. That gives me 8,008, just so you have that as a reference. That's the number for that. Then we would times that answer by point. I would not clear my calculator. I would just go ahead and times it by 0.22 to the 6th. And then without clearing my calculator, times that by 0.78 to the 10th, using your exponent button as needed. And this to 3 decimal places, according to the directions, is about 0.076. So it's about 7.6% if you were to turn that into a percentage, but they just asked us the probability. So I'm not going to turn it into a percentage. Okay. Now it says find the probability that at least 2 of the students, at least 2 means 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9 or 10, all the way up to 16. I don't want to calculate that. So if you have X can go from 0 to 16, either no one's working full time or everyone is, I would use the complement here. So the probability of at least 2 is 1 minus 0 people working and also minus 1 person working full time. Okay. That's everybody else because 2 to 16 is what they asked for. At least 2 is greater than or equal to 2. So I'm going to do 1, which is total probability for the whole group, like for every possibility, minus these 2 specific scenarios. Now, for both of these, you have to do a CPQ formula. You have to do that binomial formula. So that's going to be 16 choose 0.22 to the 0.78 to the 16. This is choose 0 people to be full-time workers. So that means 0 successes, 16 failures, where we're considering failure not being a full-time worker. I know that's not, sometimes failure is a negative connotation, but that's what we're looking at. Then we're going to have 16 choose 1 for pick 1 person to be a full-time worker. And then we have 0.22 is 1 success, which means we have 15 failure in that scenario. Okay. So we're going to work out both of those. So 16 choose 0 is 1 times 0.22 to the 0. We're still going to be 1 because 0, anything to the 0 power is 1. So it's really just that 0.78 to the 16 that gives us a value here for that first one. And I'm going to round that to 3. Actually, I'm going to round it to 4 decimal places here, and I'll round it to 3 once we're done. So this is 0.0188. I know that's extra. That's an extra place that we didn't need, but it's just to make sure we didn't round too early. And then 16 choose 1 is 16 times 0.22 to the first, is that's going to give me 3.52. And then times 0.78 to the 15th, that's going to give me roughly 0.0847. It keeps going. And then we're going to subtract this and round our final answer to 3 decimal places. So 1 minus 0.0188 minus 0.0847. I'm getting 0.8965, which if we round to 3 decimal places would be 0.897. Okay. So that's the probability that at least 2 of the 16 students work full time. All right, and then we have numbers 25 and 26. So 25 says the mean clotting time of blood is 7.35 seconds with a standard deviation of 0.35. So they're giving us a mean and they're giving us a standard deviation. Typically, when you see that in the problem, you're going to be looking at the normal distribution and you're going to be figuring it out using the z-scores. So we want to do less than 7 seconds. That's one of the questions. So what's the probability that we're less than 7 seconds? And then more than 8. Notice neither one of those is including the endpoint, but when you're doing the normal distribution, that doesn't really matter. You just use the formula for a z-score. So the z-score is the item in question, which is 7, that's our tipping point, minus the mean, which is 7.35, divided by the standard deviation, which is 0.35. Now that's going to give me a value that I'm going to use my standard normal curve table for. So 7 minus 7.35 divided by 0.35, that's a -1. Now I will look that up in a second. I'm going to go ahead and get both z-scores and then we'll pull up the table. For this one, we're doing 8 minus 7.35 and dividing that by 0.35. So 8 minus 7.35 divided by 0.35. And usually z-scores, we go to 2 decimal places. So this is 1.86. Okay. So work that all out and get that. Now let's talk about what this visually looks like. So we know what we're looking up on our table. So remember, 0 is the mean or middle part. We're at -1 means we're below it. We want to know less than -1. So we want this area right here, this little tail. Unfortunately, the table we get always gives us the value from the mean, which is 0, to the z-score. So your table is going to give you this blank spot right here. We need to do 0.5 minus the table value to get our probability, okay? On the other one, just so we know what we're looking for ahead of time, we're at 0 for the mean. 1.86 is way up here. It's on the positive side. We're doing more than that. So again, we're doing a tail that is beyond this point. So we're going greater than that. Again, when you look at your table only tells us mean, which is 0, to a point. Okay. So again, because half of a bell curve is 50%, we'll do 0.5 minus t. So these are both the same kind of problem. It's just one's on a less than spectrum, the other one's on a greater than spectrum, but they're both going to be that we need to find the table and then we need to figure out what the tail is. Okay. So let me pull up and share the table that we need to look at. So just hang on just a second. I have to go back to our class and I think I had it in announcements. Now I will be printing this table for you if you're testing in person on Thursday. If you're testing at a testing center, should be getting a copy of it with your test. So just be aware of that. So let me pull this up and share it the same way on the open edge. Okay, so let's see if it is going to share this correctly. So double check. We've got the edge open and I wanted it to open the table, not the final review again. So hang on just a second. Did I just open the wrong one? Yes, that's all that happened. So hang on. There we go. So there's the table. So this is what we have. Okay, So when you're looking for the values, notice 0 to the z-score, and that's good for either 0 to a positive z or 0 to a negative z. It's a symmetric curve, so it works both directions. So when we look at this 0 to -1, so we look up -1 or +1 for us because our table only has positives. Remember, it's a 2 decimal place thing. So 1 is just 1.00. So that is this first value right here, 0.3413. So this table value right here, this one right here is 0.34, and I just forgot what it was, 13. Okay, so that's not our final answer. We want this area. So 0.5, half of the bell curve minus 0.3413, that's going to tell me that probability less than 7. So 0.5 minus 0.3413 is 0.1587. So there's that probability. Now we're going to look up this one. So we look up from 0 to 1.86. So 1.8, and then the second decimal place is a 0.06. So you need to find in your table where those two row and columns would overlap. That's going to be right here to 0.4686. So that's this value, 0.4686. So if we want the tail above that, we do 0.5 minus that. So 0.5 minus 0.48 or 4686 is 0.0314. So that is how you use the standard normal table. Now, if you were just looking from 0 to 1.86, obviously you just use your table value. But if you're looking for something above that or below it, or maybe you're adding, maybe you're doing everything below 1.86, you would add this value to 0.5 because you'd have to go all the way shading down the whole other half. So you really should draw a picture so you can kind of think about how to calculate that area. Okay. And then the last one is number 26. So it says a coin is weighted so that the probability of obtaining a heads in a single toss is 0.4. So notice that's binomial. That's a probability of success. So getting a heads, we're considering success to be a heads. When we flip it, that probability is 0.4. It's not a fair coin. We're going to toss the coin 50 times. So that's our N. That's the number of times they're going to do the trial. Probability of getting not head then would be 0.6, because remember this has to add to 1. What is the probability of obtaining between 15 to 22? So we're looking for probability of 15 to 22. Now, when you ask it this way, you are in the binomial distribution because you're looking at how many successes you have. We're going to approximate this using a normal distribution. You have to remember, a normal distribution is a smooth curve, whereas a binomial distribution is a bunch of histogram bars, okay? So just think about this. I'm just drawing in some bars for visuals right here, okay? If this right here is the value of 15 and this one is 22, and again, I don't know if that's where they fall on the bell curve, but I'm just giving you a reference. The problem is if we want to shade all of those bars, you have to shade a little below your mark and a little above your mark. You actually have to shade more than just the line. That's called continuity correction. That correction to go from the binomial to the normal means we need to do a half step on either side. So this steps down a half step because numbers go from least to greatest. This one steps up a half step. So this would be in the normal distribution. We want to go from 14.5 to 22.5. Okay, and that's because of that bar graph to smooth curve. That's the reason for that. So this will be what we do in the normal. Once you have that, you need two other things. In a binomial distribution, to turn that into a normal approximation, you have to have a mean and a standard deviation. Because remember, our z-scores do an item minus a mean divided by the standard deviation. So if I want to do the z-score of 14.5, I have to have a mean and a standard deviation. Luckily for us, we have two formulas in a binomial distribution that tell us how to do that. Your mean is just n times p, which for this one is 50 trials with a success rate of 40%, so 0.4. So this will tell you if I flip that coin 50 times, I expect to see 20 heads, okay? Now, the standard deviation is the square root of n, p, and q, all multiplied together. So square root of 50 times 0.4 times 0.6. So 50 times 0.4 and then times 0.6, and then that's 12. So we need to take the square root of 12. And you usually round this to 2 decimal places for this part. It's 3.46. So now I have a mean and I have a standard deviation, and I have actual items. So for the first one, we're doing 14.5 minus 20 over 3.46. Okay, that's the formula for that z-score. If we're using the normal approximation to this the binomial. So 14.5 minus 20 divided by, and that's going to be a 3.46. I round that to 2 decimal places. That's going to be a rough z-score of negative 1.59. Okay. So then for z of 22.5, because remember, that's how we read our table. We need a z-score. So 22.5 minus 20 divided by 3.46. So 22.5 minus 20 is 2.5. Divide that by 3.46. Round it to 2 decimal places. I get that that's roughly a z-score of 0.72. Now, if you think about it, I kind of actually drew this right because one of mine is below my mean and the other one's kind of above my mean. I didn't know that off the top of my head, but when I saw 20 here, I was like, oh, I actually kind of drew that correctly. But I'm going to redraw it now that I actually have values for the z table. So 0 is in the center when you turn into the normal curve and you have your z-scores. The negative 1.59 is a little bit further down away than a 0.72 would be above. Okay. So here's the deal. You have 2 parts when you have an above and a below. You're going to find the table value for 1.59, and that's going to give you the yellow area that I just highlighted. You're going to find the table value using your normal table for 0.72. That's going to give you the pink area from 0 to 0.72. And then we want all of the area. So we are going to add the 2 areas together. Okay, so let's go to our table. 1.59 is the same thing as negative 1.59 when you're doing a symmetric table. So 1.5 and then 0.09 is way over here. Follow those over. That's 0.4441. So I'm going to write that down on this side. So 0.4441. So that is that area. Okay. Then we're going to look up at 0.72. So 0.7, the 2 is the second decimal place. We find that one. That's 0.2642. 0.2642 is the pink area. We want everything in between, so we add them together. So 4.4441 plus 0.2642, I get 0.7083. Okay, and they did say approximate the probability using a normal distribution and round our final answer to 2 decimal places. So that would be 0.71 if we follow our rounding rules. Okay, so that is how you handle a normal distribution approximation for a binomial setup. Okay, the big things are the takeaways of half stepping to do the correction from bar graph to smooth curve. And then the other thing is you have to know how to find your mean and standard deviation. Once you have those 2 things, it's just find the z-scores and read the table. I hope you found this very helpful.